We are still working in chapter 19 about bivariate statistics, and we are going to talk about the least squares regression line today. So we talked about how to do a line of best fit by eye, just eyeballing it up with the mean coordinate. But now we're going to talk about how to actually calculate it. And your calculator will calculate it for you, or Excel when you get into the IA. So what the linear regression does is it fits a line to the data that minimizes the distance from each data point to the line. So it does these calculations in order to angle your line kind of up and down in order to make this vertical distance from each point as small as possible. So the equation is in the form of y equals ax plus b, or you usually think of that as y equals mx plus b. So a is going to be your slope and b is your y-intercept. And it's such that the distance, this thing here, is minimized. But let's just go ahead and do this example. So this is from your textbook. Take a second, get your calculator out, go ahead and put your data into the L1 for your x values and L2 for your y values, or wherever you put it, but just remember it. I already have the data entered, so if I hit stat on my calculator and I hit edit and enter, you can see that I have the data there. So first thing I'm going to show you how to do is how to graph it. Because this information is in stat, instead of hitting graph, we're going to hit stat plot, which is second y equals. So I'm going to turn the stat plot on. Mine's already on, but you would hit enter on one, hit enter on, and then you can choose. Notice we could have done box and whisker plots on our calculator, and I can show you how to do that later. But this is all set up so I can quit and get out of there. And if I'm going to set my window now. If I look at my data, my X data goes from, what is that, 36 to 65-ish. So I made the smallest X value 20 and the biggest X value 100, and I said let's count by 20s. In the Y's, the smallest value is 60 and the biggest value is 250. So I made it 0 to 300 because I wanted to see how this line looks. When I hit graph, you can see there is all of my data. Yours won't have a line in it yet because you might not have run it yet. All right, next thing I'm going to do, go back to stat. So I have my data in the appropriate places. I'm going to calculate. I'm doing the lin reg. That's number 4, lin reg. So I hit 4. My data is in L1 and L2. It is not a frequency list. And here's how I get the line to graph. I need to tell the calculator where to store the equation. So I hit vars to choose the location. I hit y vars for y variable, and I choose function, which is number 1. So I hit enter. And then I put it in Y1. You can put it wherever you want. If you have something in Y1 already, it might not graph. There might be an error. So you might have to go back and clear Y1, but I'm going to hit enter. You can see the Y1 is there, and now I can calculate. So here is all of my information. It's in the form of y equals ax plus b. So A is 4.178, B is negative 56.69, etc. And then R down here, my regression statistic, is 0.894. So there is a correlation between these two, and it is positive. All right, so let's answer some questions. So we use technology to find the equation of the regression line. So I would literally write down the equation with the values of A and B. So here is the regression line. Y equals 4.18x minus 56.7. Then it wants me to state and interpret the gradient of the regression line. So the gradient here, that's another word for slope. That's 4.18. We know that. But I need to say what it means. So look at the y value and the x value. Remember that your slope is the change in y over your change in x. So in this case, it's going to be the change in the grocery bill over the change in income. And since this is 4.18, but it's in, that's our pounds over 1, but that's in thousands of pounds. So we end up with our income as M is 4.18, which is grocery per income. And if I'm explaining it, I would say that the grocery bill increases 4.18 pounds per every 1,000 pound income increase. Remember, that's just based on the information that they told us, that this is in X thousand pounds, not per 1 pound. Part D, we want to estimate the weekly grocery bill for a family with an annual income of $95,000. By estimate, they actually mean calculate using the regression equation. The regression equation is an estimate, and so therefore that's why you're estimating. So in order to get full marks, I would substitute 95 in for X. That's because the equation is in thousands of pounds, so I don't need to write 95,000, I just write 95. Do that math on my calculator, and then I end up getting 340 pounds on groceries. So if a family made 95,000 pounds per year, we would expect that they're spending about 340 pounds on groceries per week. Part E, estimate the annual income of the family whose weekly grocery bill is 100. So grocery bill is Y, so we're going to plug in 100 for Y, and then we are going to solve the equation. So we add 56.7 to both sides, divide by 4.18, and we end up getting X equals 37.5. So we could conclude that people spending about 100 pounds on groceries per week make about 37.5 pounds per year, 37,500 pounds per year. And then finally, are the estimates likely to be reliable? Well, I mean, if we look at part D, 95,000 pounds is pretty far outside of our income range. So this is not going to be as reliable. This would be an extrapolation. At some point, like, the amount you spend on groceries is going to taper off. Just because you make more money doesn't mean you keep spending money on groceries. And then in part E, 100 pounds per week on groceries is within our data range. So therefore that would be interpolation. And yes, it is likely to be reliable. Thanks.